Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 9.2, length of line segments. Specifically, we're going to go over the long way and shortcut way of finding the length of a line formed by 2 points. We're also going to briefly discuss some real-world problems that you can use that information for. So let's get started. We're going to find the length of line segments that happen to be on the x-axis and y-axis. So we're going to find the lengths of line segments line AB, line CD, line EF, and line GH. So the long way of doing this is simply by graphing your points, which this has already been done for you. Not everything is always going to be done for you, so be aware of that. Now, to find the length of a line, your first step, assuming that you already have graphed your points, is to look at what your interval is. So pay attention to your interval. What do I mean by interval? Interval is what are your numbers counting by. Not all coordinate planes count by 1, so be aware of that. Second, after you pay attention to what your interval is, or what your numbers count by, and assuming you have already plotted your points and you have a line, you simply count. All right, so let's get started. Our first one is line AB. So I keep saying the word line. That's because we have a line above those 2 letters. So again, when you have a line above 2 letters or something like that, that symbol there means line. So I want the length of line AB. So length of line AB is, so A has already been plotted, not pointed, it is a point. B has already been plotted, and then I'm going to look at my interval. They all count by 1s, and then I count. So 1, 2, 3, 4, 5, 6. So line AB is equal to 6 units. Units is our label since we aren't given any other choice or option. All right, next, we want line CD. So line CD. And the order of the letters doesn't necessarily matter in this context. Okay, what's the length of line CD equal to? So it's already been graphed for us. How nice. So C is right there. D is right here. They formed the line. We simply look at what we're counting by. Still counting by 1s. It's the same coordinate plane. And we count. So 1, 2, 3, 4. So line CD is 4 units long. Third one. We want the length of line EF. So line EF is equal to, so they've already done it for us. They've plotted point E, they've plotted point F, they formed a line between them. We are counting by 1s, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. All right, one more. Line GH is equal to, let's see, line GH is up here on the between quadrant 1 and 2. So they plotted G for us, plotted H, connected it with a line. So we're counting by 1s. So step 2, count. 1, 2, 3. So line GH is equal to 3 units long. Pretty straightforward. This method is best when graphing, or actually it's best when points have already been graphed or plotted for you. Otherwise, I would recommend using the shortcut, which I will show you on the next page. All right, so let's do a few practice problems. We are not going to do all of these. We're just going to choose to do a few of them. So this video is not going to be 2 hours long. So let's do numbers 1, 3, and 5. So we're not going to use any shortcuts. We're going to do it the old-fashioned way of graph. Notice nothing has been plotted for us. So I hope after these few examples, it becomes evident that we might need a shortcut so you're not having to waste a bunch of time in making a coordinate plane, plotting your points, and then counting. So first one, we want the distance of line CD. So point C, point D, they're going to form a line. So we're going to have to plot point C at 3, 0. So don't forget, left or right first, up or down second. They're called XY pairs for a reason. So 3, 0, right to 3, up or down nowhere. That's point C. D is at 8, 0. So right 8, up or down 0. D is right there. We're going to connect them with a line. Now I can simply count. Now first, make sure you pay attention to the interval. The interval is 1. So 1, 2, 3, 4, 5 units long. So line CD is 5 units. All right, next example we're going to do G and H. G is at -7, 0. So start at the origin, go left to -7, up or down 0. So G, all right, H, 1, 0. So start at the origin, go right to 1, up or down 0, nowhere. Connect the 2 points with a line. And then, again, we're counting by 1, so let's count. So 1, 2, 3, 4, 5, 6, 7, 8. So line G, H equals, already forgotten, 1, 2, 3, 4, 5, 6, 7, 8. 8 units. All right, one more example. Let's do number 5, 0, -6 for M. So go left or right 0, down to -6. And that's point M. All right, N is at 0, -3. So left or right 0, down to -3. Connect your 2 points with a line. And pay attention, we're counting, or the interval is 1, so we're going to count by ones. So 1, 2, 3. So line NM or MN, again, it doesn't necessarily matter since these are just line segments. It is equal to 3 units. Now, the benefits of doing it this way is, well, if you already have them graphed, it's as easy as counting. But let's say you don't have graph paper, or you don't want to take the time of making a coordinate plane because, not everything is going to be printed nicely for you like this. You might want a shortcut, which is what I'm going to show you next. So, how can you find the distance of line segments without necessarily depending on a coordinate plane or graphing it? There's basically a 2-step process. First step is to look at the coordinates that are not identical. You might be like, I have no idea what you mean by that. Don't worry. We're going to go over an example. Several. So you're looking for the things that are not identical. So if they are identical, ignore that. And again, I'll show you an example in just a bit. After that first step, you have an option. First option, if those coordinates that are not identical, if their signs meaning positive or negative, are the same, so the signs are the same, you are going to subtract the absolute values. So, the same signs you're going to subtract. So you can think of SSS for same signs subtract. All right, that's one option. Option 2 is, what if you have different signs, like one of your numbers is positive and one of your numbers is negative? So if you have different signs, you're going to add the absolute values. So, different signs add, DSA. So, the easiest one to remember is the SSS. You're going to subtract, then the different signs, you're going to add them. Again, you're subtracting or adding the absolute values. So let's go over a couple examples of what that looks like. So we're going to find the length of line segments, line RS, line MN, and line PQ. We're actually going to do a couple of them. Now, they've already been graphed, so obviously the best way would be to simply look at what the interval is counting by, or what your interval is, and then count. But what if it wasn't graphed for you? That's what we're going to go over. So let's do line RS first as an example. Obviously, I can tell that it's 4 units. But let's show you what you would do if you didn't have a nice coordinate plane. So what are we going to do? We're going to first look at our coordinates. So R is at 2, 2. Our S is at 6, 2. So if I want to know the length of the line segment without having to graph a thing, I just need to follow this 2-step process. So first step, look at the coordinates that are not identical. So you'll notice I stack them on top of each other. It's so I can easily see what's identical. So are those identical or are those identical? Obviously, the y values are identical in this example, so I'm not going to look at them. I want to look at the ones that are not identical. So the ones I'm concerned about are the 2 and 6. They're different from each other. That's what I want to look at. Second step, I need to determine, are the signs the same or are the signs different? Well, they're both positive. I have a positive 2 and positive 6, so I have same signs. So SSS. Same signs subtract. So I'm going to take the absolute value of 6, take the bigger one, and then subtract the absolute value of 2. So smaller 1 second. Absolute value of 6 is 6. That just means how far is it away from 0. Absolute value of 2 is 2. Again, that means how far is 2 away from 0. 6 minus 2 is 4. So the length of line RS is 4 units. And you might be saying to yourself, well, I could have just counted. Well, true, in this example you could have, but when are all the graphs going to be already nicely printed for you? Yeah, no, they're not always going to be like that. So this might be the fastest way. All right, before I go on, actually, no, I'll go over that in a little bit. Sorry, rambling. Let's do this example down here, line PQ. Obviously, it's already graphed for us, so it would be quicker to simply count, but let's practice the shortcut. And you'll realize why it's a shortcut in a little bit. All right, so P, it is at -3, -10. Q is at 6, negative 10. First step, look at the ones that are not identical. So those are identical, let's ignore them. I want to look at the ones that are not identical, so the negative 3 and 6. And then I need to determine, do they have the same signs or different signs? They have different signs. One's negative, one's positive. So different signs add absolute values. So absolute value of 6 plus absolute value of negative 3. Absolute value of 6 is 6. Absolute value of negative 3 is 3. Going to add them. 6 plus 3 is 9. So the length of line PQ is 9 units. All right, the thing I was about to mention a little bit ago. Why do we do absolute values? Let's look at the second one first, line PQ. Point P, right over here, it was at negative 3, 10. We're basically saying negative 3 is 1, 2, 3 away from 0. And Q, since it's on the other side of the axis, we're saying it's 1, 2, 3, 4, 5, 6 away from 0. So 6 plus 3, you get a total of 9 units. Now, on our other example with RS, you'll notice they're both in the same quadrant. So, on this one, R was 1, 2 away, while S was 1, 2, 3, 4, 5, 6 away. So if I want the length of this part, I just need to take the difference. 6 minus 2, and you're going to get 4. And distance is always positive, so that's why you need your absolute value. So essentially, you're taking the distances from 0 in either adding or subtracting. Okay, so back to this. This is technically the shortcut. And this is why. Let's say you have a problem that says, find the length of these lines formed by these points. Do you really want to take the time to draw a coordinate plane, plot those points, figure out what you're counting by, and then count? Well, maybe, but yeah, I don't want to. So let's do examples 7 and 9 using the shortcut. We're not going to graph that. So first example, 7. We want to find the length of line AB. So first, I'm just going to stack them on top of each other so I can quickly identify what's the same and what's not. So A is at 1, negative 2. B is at 6, negative 2. Which ones are not identical? The 1 and the 6. So do they have the same sign or different sign? They have the same signs. They're both positive. So same signs, subtract. So absolute value of 6 minus absolute value of 1. Absolute value of 6 is 6. Absolute value of 1 is 1. Subtract, you get 5. So line AB equals 5 units. I don't know about you, but I feel like that was a lot faster than having to make a coordinate plane, writing out all the numbers, plotting the points, and figuring out the distance. Okay, let's do one other example. Number 9, E and F. So I'm going to stack them. Again, that's not necessarily a requirement. It's just very helpful. F is at 1, 4. What's not identical? The x values. So negative 3 and 1. So do they have the same sign or different sign? One's negative, one's positive. So different signs add. So absolute value of 1 plus absolute value of negative 3. So absolute value of 1 is 1. Absolute value of negative 3 is 3. We're going to do 1 plus 3, and you get 4. So length of line EF equals 4 units. Now, one more thing before we move on. You'll notice that all of the identical units just happen to have been our y value. That is just a coincidence. It could happen for your x values. For example, on number 11 here, if I were to do this example, -1, -6, and -1, 4, the ones that are identical are those, I would cross those out, meaning I'm going to deal with these. They are different signs, so I would add the absolute values. All right, let's move on to some word problems. Okay. We're going to plot points on a coordinate plane for a real world problem and solve it. Well, technically, we're not going to plot it. It's already been done for us. How nice. All right, our example here. A plan of a rectangular garden is shown. So think of it like blueprints. The side length of each grid square is 2 meters. Very important right there. Always pay attention to what your interval counts by. So, 2 meters. So, everything counts by 2. And our label is meters, not units. Okay, first question about our garden. We're going to simply give the coordinates of points A, B, C, and D. So, A, parentheses. All right, A is right to 2, up to 12. So, 2, 12. Next one, B. Right to 2, up to 2. So 2, 2. C. Right to 18, up to 2. And D. Right to 18, up to 12. So just extra practice in plotting and finding coordinates. All right, B. We're going to find the length and width of the garden in meters. So let's find the length first. Don't forget, we're counting by twos. So that would be 2 meters, 4 meters, well, another 2 basically. And we keep going. So we have 2, 4, 6, 8, 10, 12, 14, 16. So 16 meters. And that is our length. Next, let's do our width. So again, each is counting by twos. So 2, 4, 6, 8, 10. So our width is 10 meters. I could use a shortcut, but again, it's not really a shortcut if things are already graphed for you. All right, next. Let's actually answer those real quick. So we're going to say the length is 16 meters. And it said the width. So the width is 10 meters. So we've answered both of those questions. Okay, next question. Find the area of the garden in square meters. So, what's the formula for area of a rectangle or square? Because the formula works for both. It is A equals LW. Area equals length times width. Again, this only works for squares or rectangles. Don't use it for any other shapes. It doesn't work. So, area equals, what's the length? Well, we found that. 16. It's like they knew we were going to have to do it. What's the width? 10. So, again, when letters are next to each other, it means multiply. So we're going to do 16 times 10. It's 160. What's our label? Square meters. So we're going to write m to the power of 2. M squared. In words, you can write the square first. But when you use the symbols and numbers, the exponent comes at the end. Now, what does this mean? This means that garden has 160 squares. the size of a meter. Meter is much bigger than that, obviously. So imagine everything is, because this is counting by twos, you essentially have 1 meter there, 1 meter there, another meter, and so forth. So imagine 160 of those square meters in there. All right, let's officially answer. It says find the area. We're going to say the area is 160 meters squared. Pretty big garden, kind of. All right. D. Find the perimeter of the garden, A, B, C, D, in meters. So perimeter means add all sides. Not area, so you're not going to have those units right there. Just going to say meters. Okay, so what are our sides? We have 16 and 10. Well, there are 4 sides. So what are these 2 sides? Well, this is a rectangle. So opposite sides of rectangles are equal. So that means this side is also 16 meters. And that means this side is also 10 meters. So we have 16, 16, 10, and 10. So 16 plus 16 plus 10 plus 10. So 10, 20, 30, 40, 46, 52. 52 what? Meters. So it says find the perimeter. We are going to say the perimeter is 52 meters. Now, why would you want to know the area or your perimeter? Well, maybe you need a fence, so you need to know how much fencing to buy. Maybe you need to buy dirt or whatever else you need to put in a garden. You're going to need to know how much area you need to cover or fill. All right, last example for this. There's a palm tree. Where? Well, we're going to have to find it. That's what kind of problem this is. It's like treasure hunting. X marks the spot. Actually, it's going to be point E. Anyways, there's a palm tree. It's planted at point E. It's 12 meters from line AB, and it's 4 meters from line AD. We're going to give the coordinates of point E, and we're going to plot it on the coordinate plane. We're going to do this first, and that second. So first, let's plot it. So we're going to have to find it. Their directions say it's 12 meters from line AB. So line AB is on the west side. We're going to go 12 meters. So don't forget, this counts by 2. So 2 meters, 4 meters, 6 meters, 8 meters, 10 meters, 12 meters away. So that palm tree is somewhere on this line right there. Next, it's also 4 meters from line AD. So 4 meters from line AD. Line AD is on the north side of the garden. Don't forget, you're counting by twos. 2 meters, 4 meters. That means that palm tree is somewhere along that line. Look at where they intersect. X marks the spot. So your point E is your palm tree. So we have plotted it. Just see above. Second, we need to give the coordinates of point E. So point E is at right to 14 up to 8. So 14, 8. Again, this would be like what I call a treasure hunt problem. You essentially have to follow the directions to find where the point is. Look for where the lines intersect. All right. We have a couple more scenarios. First one. And my stomach is growling. All right. In the diagram, triangle ABC represents a plot of land. The side length of each grid square is 5 meters. So, always pay attention to what your interval counts by. Use a diagram for numbers 13 through 15. All right, 13. Give the coordinates of A, B, and C. So, A is at right to 10 up to 20. B is at right to 10 up to 5. And C is at right to 30 up to 20. All right, we have plotted all three of those points. All right, 14. Mr. H wants to build a fence around the plot of land. Why? Maybe he's trying to keep the unicorns out. Oh, wait, no, they don't exist, so I don't know what he's trying to keep out, but it's not them. If line BC is 25 meters, how many meters of fencing does he need? So, you'll notice they gave us the distance of the diagonal line. Why? It's not because they were being nice. In 6th grade standards, we don't learn how to find the distance of diagonal lines. We just find the distance of straight lines. Diagonal lines, you'll learn in 8th grade, typically. All right, so we just need to find the distance of line AC and line AB. We're going to add all three to find out how much fencing he needs to buy to keep whatever it is he wants out. So, line AC. Don't forget, we're counting by fives. So, 5, 10, 15, 20. 20 meters. Next, line AB. 5, 10, 15. So 15 meters. So we're going to take 15 plus 20 plus 25. And we're going to get 10, 20, 30, 40, 50, 55, 60 meters. So Mr. H needs 60 meters of fencing to keep the unicorns out. Oh, wait, no, they don't exist. Maybe it's wolves. He wants to keep wolves out. Yeah, that's right. All right, next. 15. A pole is located at point D on the plot of land at a distance of 10 meters from line AB and 5 meters from line AC. Give the coordinates of point D. All right, this is another what I call treasure hunt problem. So let's follow the directions and see where the lines intersect. 10 meters from line AB. So line AB is on the west side. So it's counting by fives. 5, 10. So 10 meters. It's going to be somewhere along that line. There's not many options for it. Next, 5 meters from line AC. So that means 5 meters from the north side. 5. So they intersect right there. So this is point D for pole, right? No, that doesn't really match. Anyways, it's at right to 20 up to 15. Those are your coordinates. Again, you're looking for where the lines intersect. So 5, 10, and then 5. So X marks the spot. That's where the pole is going to be. Last scenario. In the diagram, rectangle PQRS is a parking lot of a supermarket. The side length of each grid square is 4 meters. Always note what it counts by. Use a diagram to answer numbers 16 through 18. 16. Give the coordinates of PQRS. So, point P is at right to 16 up to 44. Point Q is at right to 16 up to 4. Point R is at right to 36 up to 4. And point S is right to 36 up to 44. Don't forget, always go left or right first on the x-axis because the first value is your x number, and the second number tells you to go up or down. Since this is quadrant 1, you're only going to be going right and up in that order. All right, 17. The manager of the supermarket wants to build a concrete wall around the parking lot. I don't think he's going to be a manager very long if he keeps people out. What's the perimeter of the wall? Okay, so I need the side lengths, essentially. So everything is already graphed for us. So we just simply need to look at the interval and count. So we're counting by 4s because our interval is 4. So let's find the north side. So again, we're counting by 4s. So 4, 8, 12, 16, 20. So the north side is 20 meters. That means the south side's also 20 meters. It's a rectangle. All right, let's do the west and east side. So again, each counts by 4. However, I really don't want to count that much. So let's just speed it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units times 4 each. 10 times 4 is going to be 40. So this is going to be 40 meters. I could also use the shortcut and simply take my values that aren't the same and add or subtract the opposite values. All right, that means this side's also going to be 40 meters. And we were finding perimeter. That means add all sides. So 40, 40, 20, and 20. So let's show our work. 40 plus 40 plus 20 plus 20. 40, 80, 100, 120. We're doing meters. Let's write our sentence. The perimeter is 120 meters. And this manager is in big trouble because, well, if you build a wall, how are the customers going to get in there? Yeah, I don't think he thought that through. All right, last problem. The entrance of the supermarket is at point T. How they are going to get in there, I don't know because, well, he built a wall. It lies on line PQ, and it is 8 meters from point P. So again, another treasure hunt problem, but this time it's the entrance. Okay, so first, it's on line PQ. So it's on that line somewhere. That's where the entrance is. Next, it's 8 meters from point P. So there's point P. It's 8 meters. Don't forget, we're counting by 4s. So 4 meters, 8 meters, right there. So again, 4 meters, 8 meters. Right there is point T, and that's our entrance. So give the coordinates. T is at right 16 up to 36. All right, I hope this has helped with finding length of line segments and using that information to help solve some real world problems. If it hasn't, I hope you can find what you're looking for elsewhere. Y'all have a great day.